أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. Assalamu alaikum wa rahmatullah. So today is August 6th, 10:41 a.m. Eastern Standard Time on my side of the world. We have Sister Momna Shahid. She is a student of EduQual Level 6. She'll be going through her examination. The topic is very interesting. Multi-tenant SaaS observability platform with open telemetry, Tempo, and Cortex on AWS and IBM Cloud, right? Uh, we were just discussing before coming into this meeting. I was in a meeting with my team, technical team, and we are now also looking into going towards Alibaba Cloud as well, right? Because I think that will bring us almost 80% of the savings. 80%. So Alibaba is cheaper. It's like 80% cheaper than AWS Cloud, something like that, right? There are certain ways of how we can reduce the AWS Cloud as well by doing reservations and stuff like that. But this is one of the things. So the topic is the real topic, which is very active in the industry right now, and many organizations are looking into it, how they can further reduce the costs. Okay.
Yes.
Um, you have to explain to me building a fully observable multi-tenant SaaS platform capable of ingesting and analyzing traces, logs, and matrices using vendor neutral open source technologies. Okay. The
Yes.
architecture should support horizontal scaling, tenant separation, and alert correlation across AWS and IBM Cloud. So collect distributed traces using open telemetry, Grafana Tempo, store matrices in Prometheus, and scale or using Cortex, using Fluent Bit Loci for centralized logging per tenant, right? Then there are certain areas, multi-tenancy controls, cross cloud deployment, industry applications, open source and cloud native tools. You will be given 15 minutes minimum, maximum up to 20 to 25 minutes to present your topic, right?
Yes.
After which we will go and discuss deeper into the question parts, where we will go and discuss all kinds of questions related to this topic, inshallah. Okay. Are you ready?
Yes, sir.
Do you have any questions before we start?
No, sir.
Okay, let me put the timer to 25 minutes. Okay, you may share the screen.
Okay, yes, just give me a minute.
So this is RQF level 6. Okay,
Is my screen visible?
it is loading. Yes, it is visible.
Okay.
Okay, Bismillah ar-Rahman ar-Rahim. You may start now.
Assalamu alaikum. Good afternoon, everyone. My name is Momna Shahid, and I am excited to present my project for the Diploma in Artificial Intelligence Operations. The title of my presentation is Multi-Tenant SaaS Observability Platform using OpenTelemetry, Tempo, Cortex deployed on AWS and IBM Cloud. This project demonstrates how we can build a modern, scalable, and secure observability solution for SaaS providers that serve multiple tenants across cloud platform using only open source and cloud native tools. Let's move to what the let's start by the outline of for my agenda of my presentation. I'm let's I'll start with the project goals, what problem the solution addresses, then move to a system architecture overview, how different tools integrate in this platform. I'll explain distribute traces with open telemetry and Tempo, then cover matrix monitoring with Prometheus and Cortex. Next is centralized logging with Fluent, Bit, and Loki. We'll go into TNet level control and role-based access control using Keycloak and Open Policy Agent. I'll show how we achieve trace correlation and alert correlation. Then discuss cross cloud deployment using Terraform across AWS and IBM Cloud. We'll also look at the industry use cases for this platform. I'll summarize the tool stack summary. Then what solutions the pro, then what then we'll talk about the benefits of my solution. I'll also introduce how AI enhance the observability in this architecture. Finally, in the end, I'm gonna share my final thoughts about this project. The goal of this project, the goal is my project is fully established SaaS platform, uh, platform. Um, Means it can serve multiple independent customer or tenant securely. Each tenant must be monitor their application with isolation, privacy, and access control using in, access control without interfering with others. We achieve observability using three pillars, which is traces, matrices, and logs. These pillars give us deep insight into application behavior. Everything should be deployed across AWS and IBM Cloud, enabling failover, redundancy, and disaster recovery. Uh, we use open source tools to keep our costs low and ensure vendor independence. This platform is intended for real SaaS companies such as e-commerce firms, education platforms, and also logistic providers, all of which rely heavily on uptime and application performance. Then we'll talk about system architecture overview. Um, the diagram Here's the diagram of system architecture overview. Um, let's break it down layer by layer. At the ingestion layer, we deployed open telemetry agents inside each application, pod, or services. These agents collect um, these agents collect telemetry data, specifically logs, traces, and matrices from every service in our SaaS platform. Um, uh, in our processing layer, Grafana Tempo stores and manages distributed traces. Um, Prometheus collects and scrape matrices, while Cortex is used to scale Prometheus for multi-tenancy and horizontal scaling. Fluent bit forward logs to Grafana Loki, which is a highly efficient logs aggression system. In the security layer, we have Keycloak, which is an open source identity and access management tool, and is used for Tenant based authentication. Open Policy Agent enforces authentication policies, ensuring each tenant can only access their own data. Um, over over diagram also explain the same architecture which we have. Just give me a minute. Let's move to the next slide, which is distributed tracing with open telemetry and tempo. One of the core component of observability is tracing. We use open telemetry. To collect traces from the services written in different programming languages. It supports Python and many other programming languages. Um, each trace should show the life cycle of a request, how it flows through different services, where it spends time, and where bottlenecks occur. These traces are ingested by Grafana Tempo, which is highly scalable and cost-effective trace backend. For example, in an e-commerce scenario, when a customer when a customer click on checkout, open telemetry tracks how the request gone from the front end to the order service, then to the payment services, and finally go to the industry service. If there's latency in payment processing, it will visible in the trace. Tempo integrates seamlessly with Grafana dashboards, alloy engineering to analyze requests and detect performance issues quickly. Let's talk about matrices collection with Prometheus and Cortex. Uh, Matrices is the second pillar of observability. Prometheus collects real-time matrices such as CPU usage, memory usage, and latency requests. However, Prometheus alone is not suitable for the multi-tenancy or large-scale environment due to its single-node nature. Um, that's where Cortex come in. Cortex scale horizontally with using microservices such as distributor, ingester, querier, and ruler. It stores matrices in chunks in an object store in an object storage like Amazon S3 and IBM cause. Cortex enable multi-tenancy. Each tenant data is separated and isolated using unique tokens and namespaces. For example, in our SaaS platform, we can have one Prometheus instance collecting matrices for tenant A and another for tenant B, both writing to Cortex with isolation. The use case for matrices collection with Prometheus and Cortex includes track per tenant, tracking per oh sorry tracking SLOs like 99.99% uptime per tenant. Let's move to the centralized logging with Fluent Bit and Loki. Logs are the third part of observability. We use free. Logs are the third part of observability. We use Fluent-Bit, which is a high weight log forwarder to collect logs from containers, services, and hosts. Fluent-Bit sends log to Grafana Loki, which stores logs efficiently using metadata based indexing, not full text indexing. This greatly reduces the storage cost. Logs are tagged per tenant using labels like tenant ID and ensuring separation. The use case includes a tenant reports login failure. We query Loki using a tenant ID and find failed login attempts from a misconfigured auth service. The provider's precise diagnosis per tenant. Let's talk about tenant level control. Let's talk about tenant level control and role-based access control. Multi-tenancy is not just about data isolation. It also requires strong identity and access control. For authentication, we use Keycloak, which is used to handle identity and login across tenants using role policies. For each user is associated with a tenant and assigned roles like admin, viewer, also DevOps. For authentication, we use Open Policy Agent. OPA reads JSON-based policy rules like JSON copy. Um, um, a user can only access resources that belong to their own tenant. This design ensures data privacy compliance with regulation, for example GDPR, and also custom permissions per tenant. let's talk about trace virtualization and alert correlation. Um, um, Prometheus Alerts Manager triggers an alert when CPU usage is across 85%. In Grafana, the engineer clicks on the alert and is taken to the corresponding traces in Tempo. Uh, then they can view related logs from Loki for that service and time window. For example, an alert says high DB latency. Um, Tempo shows Tempo shows a slow database calls in the trace. Logs show retries or timeout errors. This reduce means time to resolution, which is also called MTTR. The end-to-end correlation reduce noise, improve root cause analysis, and also support proactive incident management. Uh, to achieve high availability, we use Terraform for infrastructure as a code. Terraform allows us to automate deployment across multiple cloud platforms, including AWS and IBM Cloud. We define infrastructure using .df files such as copy, edit, etc. The benefits include if AWS has an outage, traffic can be switched to IBM Cloud. Scheduled Terraform plans ensure backups and test failures regularly. Infrastructure is reproducible, version control, and also consistent. The cross cloud strategies avoid vendor lock-in and ensures business continuity even during regional failover. The observability platform has practical applications across industries. For example, if we talk about e-commerce, it monitor products, start dropout, and also checkout error. In education, it tracks login patterns and exam submission timings. For logistics, it monitors fleet movements, real-time delivery updates, and warehouse sensor data. It also works for healthcare apps, tracking patient diagnosis, also fintech companies, which monitoring payment gateways, SaaS setup offering B2B monitoring platform. This platform is generic, scalable, flexible enough for many industries. Uh, Here is a summary of the tools. We use OpenTelemetry for Tempo and OpenTelemetry and Tempo for collecting traces, Prometheus and Cortex for matrices, FluentBit and Loki for logs, Keycloak and Open Policy Agent for security, Terraform for infrastructure deployment, and we use AWS and IBM Cloud platforms. Every component is open source, cloud native, and vendor independent, which aligning with modern DevOps and AI OOPS standards. This solution brings multiple benefits. For example, it's open source, means no licensing cost, full transparency and cost. It's also scalable because it supports hundreds of tenants and millions of telemetry signals. It's secure because it contains strong role-based access control policies and data separation across different tenants. It's also cloud agnostic. It works across AWS and IBM Cloud. Real-time monitoring detect issues if they occur. This makes it ideal for mission-critical SaaS platform that need resilience, security, and fast feedback. Let's talk how AI plays a role in enhancing observability. Uh, We use anomaly detection helps us a lot for AI helps us a lot in anomaly detection. It prevents possible downtime by AI models. It spikes it if anomaly spikes in matrices, traces, or logs before users are affected. For automated root analysis, it saves time. It saves times. AI agents can correlate logs and traces to suggest causes. If we talk if we talk about predictive maintenance, if we talk about predictive maintenance, anomalies or performance checked predictive maintenance by machine learning algorithms using historical telemetry data. For smart alerting incident response data from the past, it prioritizes alerts and reduce alert noise. For adaptive sampling, AI can dynamically adjust trace sampling in open telemetry based on system loads and importance. These AI capabilities bring intelligence into our DevOps tool chain, support proactive, not just reactive operations. With move forward to my conclusion for my project. We built a multi-tenant SaaS observability platform using the latest open source tools. The system collects and analyzes matrices, logs, and traces, providing deep visibility per tenant. With using Keycloak and Open Policy Agent, we ensure team-specific role-based access control. Using Terraform, we automate deployment across AWS and IBM Cloud. AI also enhance observability with smart prediction, alerting, and RCA. The platform is scalable, secure, and future-proof. The system empowers SaaS companies to deliver reliable services with real-time insight and relevance at cloud scale. My final thought with my project is with this platform, companies can reliably and intelligently deliver SaaS at scale, going to beyond simple monitoring. Thank you so much for your time. I hope I'll do my best.
Okay, Bismillah. Let's start the
Just give me a minute.
exam. All right, so Bismillah Rahman Rahim. So explain how open telemetry contributes to the observability in the multi-cloud tenant system.
Open telemetry collects logs, traces, and matrices from the SaaS platform, and delivered it to the backends which we choose for storing it.
Have you used open telemetry to test it out how it works?
Not yet. I didn't practice it.
Did you try to install open telemetry?
Yep, I tried to install it,
Okay.
but I didn't use it properly.
Okay. One of the labs in the basically, as per the job description from a US company and from a Saudi company that we had, was requirement of using open telemetry, right? That's why these topics are coming directly from the employers, right? That's why I'm asking you, because you will see, have you started doing Al Razak labs?
Yes, I do. I completed the Al Razak part one, and part two. I am in the labs of. I completed the labs of containerization, and now I'm doing the labs of Cube astronaut.
MashaAllah. So you're doing the QB astronaut labs, right?
Yes, sir.
This is very important for you as you move forward. After 6 months' time, every month we release Al Razak, right? For everyone, it's different schedules, right? So
Yes.
on the 7th month, you will start seeing very difficult labs, right? Where you have to install the open telemetry, configure it, get the trace logs in there, and then show all the data, right? That is also very important for you. That's good, mashallah. Okay. There are more than 50 qualifications of Red Hat Linux that we have covered from a business perspective, right?
Mm.
That's the,
Yes.
in level 6, there are more than 1,000 labs covering those things. That's a lot of labs. So, and for the QB astronaut, I think there are more than how many? Five, 3 to 400 labs, something like that.
It's um, right now I have access to 100 labs, 20 labs of each certification.
So you will start seeing more and more and more as you go forward, right? Every month you will
Yes.
start seeing more and more. I
Yes.
received an update that they are about to release a big batch for level 6, 5, 4, 3, and 2. Okay. Three,
Yes.
not two. There's no two. Okay. It's good, mashallah. um, so, what role does Prometheus and Cortex play in ensuring scalability of tenant-based metric storage?
Prometheus collects real-time matrices from and because Prometheus is a single node tool, that's where Cortex come in, and Cortex helps us to collect over Cortex helps us to scale the data horizontally, and also use the microservices like indexers, distributors, and many more.
Okay, that's good. Okay. And how does like Fluent Bit work with low key in the logging pipeline? Can you explain that?
Fluent Bit is basically a log shipper, which ships the logs to Loki, and Loki collects the logs, and Loki is a Grafana tool which stores the logs inside it.
So is there any indexing happening?
Yeah, Loki uh, Loki only indexing the metadata, not all the text of the logs. That which helps us to make our platform cost effective.
So for the security controls, what security controls you need to implement for the tenant level isolation?
Can you please repeat your question?
Like, so there is AWS and then there is another tenant, right? Within
Yes.
AWS, there are different tenants. Like, for example, if you live in a building, like apartments, there are different apartments, right? There is isolation at the floor level. There is isolation. Everyone has different doors to come in and go out. Similarly, in the cloud, there are different tenants, right?
Yes.
There is Nafi, there is Google, there is Meta, there is Facebook, like there is, all of those different companies, different services, they have these different portions of the cloud. For example, I'm just giving you an example. So, what security controls are implemented for tenant level isolation in your
Uh, we use the open policy agent for the authorization and authentication.
OPA? So, Open
Yes.
Policy Agent enforces. So, what does it enforces?
It enforces granular access policies.
Good, mashallah. What does granular access control policy means?
Um, uh,
Access control policy, what does it mean?
Asse- uh, can you please repeat it?
So, what does
I got it. I think granular access policies control. It can assess what at what level or under what conditions over it given fine gain control over data, and uh,
okay, good, good. I was just trying to see how far you can understand. Okay, that's good, mashallah. So, describe a typical alert to diagnosis workflow using Tempo, Prometheus, and Loci.
uh, this can you please repeat it?
So you have to describe to me This is a question I'm sending it to my team as well. Okay. I just sent this question to them as well. So describe a typical alert to diagnosis. Alert was there, and then we have to diagnose the workflow. What is happening? Is it like, you know, is there a latency issue? Is it a application issue? What is it, right? So describe a typical alert to diagnosis workflow using Tempo, Prometheus, and Loci. How would you do this? What happens in Prometheus? What happens in Tempo? What happens in Loci?
I think we diagnose issues using Prometheus and Loci involves monitoring matrices and logs to detect abnormal behavior, then correlation them for root cause analysis.
So the Prometheus triggers an alert,
Um,
right? The answer I'm looking, you
yes,
did the
yes,
answer, but it's not like a sufficient answer. So the Prometheus triggers an alert.
yes,
Example, latency. The engineer inspects the relevant trace in Tempo, then correlates to it with the logs in the loci to diagnose a root cause like DB timeouts, database timeouts, EC2 instance timeouts, server timeouts, cache, whatever, or failing microservices. That's how you have to provide an answer, okay?
yes.
Uh, all right, mashallah. Well, everything was okay. So let's jump in to a little bit advanced questions. This is level 6. How can open telemetry sampling strategies impact the tenant specific SLA guarantees? You know what does SLA means?
Um,
Service level agreements. So how does open telemetry sampling strategies impact
I
specific
think open
tenant specific?
telemetry supports sampling strategies to control how much telemetry data is especially traces is collected and exported. It helps us to reduce cost and also noise, which is still capturing useful insights.
I mean, yes, I will take that answer, but I won't be able to give you the full marks for that. Like, for example, the question is like, how can open telemetry, I'm looking at your presentation, sampling strategies impact tenant-specific SLA guarantees, right? First of all, you need to understand what does SLA mean? Service level agreement. If they need to provide us a service, it needs to meet this level, and that is which is written in agreement. So, for example, improper sampling, example, head-based uniform sampling may underrepresent critical traces, leading to SLA violations going unnoticed. For example, AWS was supposed to provide us EC2 instance on demand or reserve instance in a unified manner. But we noticed that the EC2 instance was not available. So, and we were not able to catch that. So that's why adaptive sampling using AI can optimize trace volume based on system importance, ensuring SLA compliance, right? So that is what we need to have, right? Because that gives us uh, one of the things, that we are looking for. Okay. All right.
Yes.
So how does Cortex use a microservice architecture to enable multi-tenant matrix storage?
I didn't. Can you please repeat the question? I just.
That's okay. That's okay. The questions are only 4 remaining, and they're going to be tough. So, how does Cortex use a microservice architecture to enable multi-tenant matrix storage? What does
I
Cortex
think
do?
Cortex scale over matrices horizontally
What does it? Yeah, horizontally, but it scales
with
on.
the microservices.
Yes, but what does it do? Cortex components like what? What are the components of Cortex?
Distributor, indexer, and the ruler.
Courier. storage
Layer,
gateway,
store.
they all work
Yes,
together, right? And what
yes.
happens? Each tenant's data is segregated how? With how do you distinguish? This is coming from a Nafi, this is coming from CNN, this is coming from BBC, this is
It
coming.
comes from open telemetry. The matrices are coming from
No,
open
with each
telemetry.
tenant data is coming with something on top of it, which is like what? With a
Uh,
unique identifier known as tenant tokens,
tenant tokens.
right? So Cortex scales horizontally and uses a consistent hashing ring for efficient data routing. Though that was a tough question, you know. So, in what scenario would you prefer low-key over Elasticsearch for tenant-based logging? What would you do? That's okay. You can have some water. Have some water. I can translate the question. किस सिनेरियो में किस मौके पे आप लोकी को यूज करेंगी ओवर इलास्टिक सर्च फॉर टेनेंट बेस्ड लॉगिंग?
I think when I want a lightweight, cost-effective, promises integrated logs aggression.
Yes, I mean Loki is preferred for observability focused use cases where logs are correlated with matrices and traces. It avoids full text logging. You know, like the difference between both of them is Loki relies on matrices and traces. Elasticsearch relies on full text indexing. It goes full blown, right? So Elasticsearch in itself is a seam, right? It's a syslog server. It has all the capabilities, right? That's what. Good
Yes.
answer. Achhi baat hai. It's good. Okay. Explain how Terraform modules can manage dynamic tenant provisioning. Dynamic tenant provisioning, what are you going to do?
For how Terraform tools manage
So, how can you use
provision.
Terraform? How can you use Terraform modules to manage dynamic tenant provision? So there are different tenants, right? Uh, how can you use, Terraform to do what? I mean, what is exactly
Terraform,
Terraform really used?
Terraform, Terraform is an open source ISC tool that automates provisioning, configuration, and also management of cloud infrastructure using code.
Okay, yeah. I mean, it defines reusable components like provisioning for, like provisioning what? Provisioning what? What do you provision using Terraform?
um, uh, cloud platform.
Yes, go on. It uses
Multi-cloud.
VPC, IAM, alerting rules, you can find anything and everything in
User
the Terraform.
uh, user and
That's okay. Let's move forward.
cloud.
Okay, so how can alert noise be reduced using AI in observability systems?
Uh, how can alert noise reduce? I think um,
Okay, what can AI really do to reduce the noise?
using.
First of all, what does noise really means in the alerts? What does alert noise means?
I'm not listening you properly. I'm not
Can
listening
I
you
repeat that
properly.
again? Can I repeat the question again?
Just give me a moment.
Can I repeat the question again?
Yes, yes. Repeat
Okay.
it.
I'm
Yes,
asking
yes.
you, how can alert noise be reduced using AI in observability systems?
Um, by using AI, by using uh, um, incident response data from the past can be used.
Yes, I mean
And
AI
AI
can.
models.
You're right. You're on the right path.
It
AI.
used to prioritize alert and reduce alert noise.
Yes, you're
For
right.
reducing alert.
AI AI can prioritize alerts based on historical response data as relates to incident response or detect duplicates, suppress flapping alerts, correlate matrices with trace logs, and looking at the presentation to reduce irrelevant alerts, and it goes on, right? Okay. All right. Let's wrap up the results. 2, 4, 5, 6, 7. Okay. How was your exam?
I think it's good.
Good. Okay, mashallah, this is good. Okay, Bismillah ar-Rahman ar-Rahim. You scored in the presentation 22 out of 25. Presentation was good. You were going through, mashallah, very good. That's 88%. Okay. In the Q&A, you secured 18.5 out of 25. The first five questions, each question is 2.5 marks. You secured full marks in the first four questions. In the fifth one, you secured one. That gives you 11. In the last five questions, 6, 7, 8, 9, 10, you secured in three questions, one and one and one. In question number 8, 2, and question number 10, 2.5, right? So that gives you 74% in the Q&A. Altogether, you secured 81% in your presentation. That's a good marks. That's a merit. You passed your exam. Very good, mashallah. Okay. So you could have done better in the Q&A, and you could have secured 88, 89%, 90% maybe, if you would have been able to answer some of the questions, inshallah. Okay. So this is my suggestion for you, inshallah. Um, you need to work on the labs. Okay. The labs will put you through all of these things. We are using all the open source stuff. There's a lot of cloud stuff in there as well. Okay. So if you go
Yes,
through all of those things, inshallah, I believe that you will be very, very good, inshallah. Okay. The second thing I would say is complete the labs, complete Al Razak Part 2. Al Razak Part 2 covers lots and lots of areas, right? There are 23 core areas. How old are you?
I am 15.
You're 15.
Yes,
You
after
want
4 months I'll be become 16.
inshallah. Okay. So, sister, this is what you have to do. Okay. I have a daughter. She's 10, mashallah. Okay. So you're 5 year older than my daughter, right? Okay, so this is my recommendation for you, just like uh, you know, just like my daughter. Okay, focus on getting the labs done. The labs are very important. Labs पे तवज्जो देनी है बेटा बहुत मेहनत करनी है उसके ऊपर Allah will give you more success. Okay,
Inshallah.
that's very important for you. The second thing is uh, after completing all the labs, go for the QB astronaut exam. You will be allowed to go for the exam at the age of
Um,
16 or something.
Sir, I also want to do the same. I asked from you, but you say you are underage for the exam. That's why I stopped.
Yes, for that exam, yes. But you will be able to allowed, I think by the age of 16, you should be allowed, something like
Yes,
that. So you will be in 4 months' time, you will be able to go for the exam anyway. Okay.
yes.
What is your goal? What do you want to become?
Um, I after that I just think to completing my labs and also clear the certifications for QB astronaut, and as soon as possible I want to place on a job because that's my biggest goal. I want to become something.
Okay. So my suggestion to you is complete the basically the labs, Al Razak Part 2. It's very important for you. Go and pass QB astronaut exams. And then then secure a job. While securing the job, inshallah, you should also work towards going and studying quantum computing or nanotechnology or something like that. That is going to help you a lot because you are young. अभी छोटी हो, पढ़ने का टाइम है. Go for it. Okay.
I also think to take the specialization from Al-Nafi
Oh,
of
yes, go for the
quantum computing.
specialization. Go for the specialization like quantum computing, right?
Yes,
Because quantum is upon us. It is coming. It may take 5 years, may take less. I don't know. It depends on the market forces, how they're going to proceed. But what I'm saying is, inshallah, you'll be very, very successful. Okay?
inshallah.
Inshallah.
Yes.
This is my recommendation for you. Say my salam to your parents. Ask them to make dua for me, my family, inshallah. Very good. You did well. Not bad. Right? Inshallah. May Allah give you more success. Do you have any questions for me?
Sir, can you please tell me my final percentage after combining all everything?
81%. 81.
I I learned everything, but I'm just confused.
It's okay. It happens. It happens, right? But inshallah, if you complete the labs and everything, 81% is good. It's not bad. It's good, right? Allah will give you more success. Keep on working hard, inshallah. Go for the specialization. You can even study and go for HND if you want, right? For Pearson, right? Because you are so young right now that you still have the time. You can establish your own company, develop a solution, pitch up an idea. You can do that, right? Because like until you are 16, 17, it's going to be difficult for anyone to offer you a job because you are very young, right? But you have the
Yes,
time to study, time to get more hands on, develop your GitHub, right? With projects. This is going to help you a lot, inshallah. Okay.
inshallah.
This is my recommendation. May Allah give you more success. Make dua for me and my family. Jazakallah khair for your time. I will see you next time, inshallah. Okay.